Thanks. Good afternoon, everyone. I'm the Director of Communications at PEER, Pacific Earthquake Engineering Research Center. We are an organized research unit of the College of Engineering here at UC Berkeley. Our constituency and our makeup is actually sponsored by, well, we're headquartered here at Berkeley, and we have a number of affiliates associated with us. We actually are comprised of 10 core institutions who are listed over on the right side. Berkeley, OSU, Caltech, Stanford, UCLA, Irvine, UC San Diego, USC, and UW, University of Washington. We work together as a team on the West Coast. We also have educational affiliates located throughout the state. In addition to our research colleagues, we also have partnerships with government and professional and industry alliances, and this is a very quick snapshot of some of our partners. We have a very strong connection with the state of California through Caltrans, through the Seismic Safety Commission, through the California Earthquake Authority, and we also have a very strong connection with infrastructure industries such as with PG&E. What is PEER about? Actually, we believe in proactive preparedness before an earthquake. That's what we're all about. So in that context, there's been a study, a Millennium Project study for the challenges in the 21st century. And there are basically 15 global challenges that we will be faced with. PEER feeds directly into 3 of these primary challenges. One of them is sustainable development, where we have throughout the world an aging infrastructure and the preponderance of natural disasters. What's the relationship between the two, and how can we best prepare for them? How can we protect the resources that we have in our infrastructure that are so fundamental to the way our communities live together in a system? That goes then to the population and resources component of it. As the world gets more populous, we find that megacities and their interdependencies between people and the services they need and what their expectations are and how they expect to live in civilizations. So we have megacities and rapid urbanization, and we also have transportation networks. PEER has a very strong thrust area in looking at infrastructure and transportation networks and their response and protection against natural hazards such as earthquakes and tsunami. And then another topic is in the field of energy, where once again we look at the impact of protecting systems, infrastructure systems, as well as lifelines. Some of the key components of PEER's mission are very actually closely tied with a philosopher's Maslow's hierarchy of needs. And it starts off at the lowest level of physiological needs. What is it that we all as individuals need? We need breathing, we need to be able to breathe, we need food to survive, water, sex, procreation, sleep, and basically, and we excrete. So we're living beings to begin with. And then that's a very basic need. And then our needs increase up the pyramid, where we are concerned with safety, being in a community with loving and belonging, and our sense of self-esteem. And then self-actualization, how we relate to others around us and what that means for us as a civilization. The lower component of this pyramid really with seismic safety, we provide basic life safety during earthquakes so that the primary functions of people are satisfied. What PEER strives to do is to increase the resiliency of that individual within the context of a community. So we want to increase the resiliency of the built environment as well as the communities, and we do that with a method called performance-based engineering. This has been actually recently referred to in the executive order that President Obama signed last Tuesday. There was an earthquake resilience summit held at the White House. And basically the policy states that the federal government recognizes that building codes and standards are a minimum a minimum acceptable level of earthquake safety for preserving lives. But to achieve true resilience, what we need to do is we may need to look at expectations that exceed those building codes so that the buildings can perform the functions as originally intended. So the peer performance-based engineering methodology is to improve the predicted behavior of buildings as well as infrastructure when subjected to natural hazards. And this slide I'll go through very quickly, but if you're technically, mathematically oriented, you'll recognize a triple integral up at the upper right corner. And that is basically an integration of a hazard, damage and cost, damage, assessment, damage, and then finally cost. So we look at hazards, we look at the analysis of structures of buildings and infrastructure, then we look at the damage that may be incurred. We're very good, actually, at predicting how systems will behave under certain earthquake expectations, as well as tsunami expectations. And then, in the end, though, what good is all this information if you're not able to relate it to how it impacts a community? And that's done in the economic sense. We look at loss analysis and come up with the variables of a decision, the value of a decision variable. Our end product is to bring the combination of all of the above to facilitate policymakers as well as the general public, as well as our industry stakeholders to make appropriate decisions about actions in response to the hazard. For example, in Los Angeles, they have last December recently passed an ordinance on their mandatory retrofit ordinance. And part of this ordinance addresses dangerous concrete buildings. Part of the methodology here is that are all older concrete buildings dangerous? To some extent, maybe some are more dangerous than others. So how do we go through a filter to understand which ones are the most critical to correct? We've seen this just this last week in the Tainan, Taiwan earthquake, where on the left side we see actually is Google Street View of the building, of an existing building. It's tall. There's maybe possibly a soft story on the ground floor. Actually, I'd like to credit Professor Tu in Taiwan for sharing these images with us. And then after the earthquake, we've seen that the lower portion of the building has been obliterated. So our research basically has fed into the LA ordinance and dangerous concrete buildings. You can see a lot of this work on our website. And going back to the executive order, once again, we're looking at code-based standards, and maybe that's good for life safety. But if we're living in a community, in a highly interdependent community where the effect of extreme damage and downtime in one area may have a trickle effect, cascading effect, throughout other parts of the state, the U.S., or the globe, Silicon Valley, China, there are very close relationships across the globe, then maybe we should be looking at something more than that for continued function. So PEER's mission is basically to look at what can be done, what are the expectations for building and system performance under different systems. We are basically working on research right now to look at wood frame buildings, single-family home wood frame buildings. We are also developing design guidelines for new bridges as subjected to tsunami loading, and that is a project that's sponsored by the Federal Highway Administration and pooled funding from 5 states, California, Oregon, Washington, Alaska, and Hawaii. We also have the U.S.'s largest 3D shaking table, and we're able to test a number of these assemblies before an actual earthquake occurs. We're able to create in the lab the ultimate test of different earthquakes in our lab. So this, in a nutshell, is what we do. We basically are interested in economic and community resilience. We do this with the problem-focused multidisciplinary research using sound engineering and scientific fundamental principles. We have very close partnerships with government agencies, the industry, and engineering professionals, so that reaches out to system stakeholders. And we also have strong national and international research collaborations, and we have a commitment to education at all levels. Thank you very much.